So now I want to switch to our best bucket as we're thinking about things, which we're labeling continuous energy commissioning. And so, Will, I want to hand this over to you because we view Dalkia as a leader in this. And Dalkia has put a lot of time and effort and brain damage into figuring this out and in many ways solving this problem for the industry.
So
Talk
yeah,
about what it means to you.
I think what we're talking about here is a semi-automated process that is, I think continuous is sort of an ideal end state. That's definitely where we're targeting for, but it starts before you automate or make anything continuous. You want to make sure you're focusing on the right stuff. So we started with a goal and said, all right, we're going to engage meaningfully with the refrigeration and the HVAC system. What does that actually mean? And what are, let's start with what the right outcome would be from, we have, clear energy mandate, kilowatt hour, true result driven perspective on the world. So that's where we approach this problem for, but we kind of came up with hey, we want to deliver the exact required refrigeration effect at any given time in the store, whether case is coming out of defrost, whether it's January, whether it's August, whether there's a door on it, whether there's not a door on it. We want to make sure that the exact amount of refrigeration effect is delivered and that you're not, surging and that we have close control over that. So you start with that, you minimize runtime of the compressors and you minimize the compression ratio as much as possible in all seasons. So start by focusing on the right stuff. And then from there, I think we took that approach and said, all right, if we focus on these 4 measures within refrigeration, 4, 5, 6 measures, whatever it was, we think that that's going to basically account for 80% of the potential upside of energy efficiency within a given store. So we're going to focus on that, and we're going to create real-time analysis that's taking continuous data streams. We're pulling it off remotely and extruding it through this analytical engine right now that kind of assembles all the data into this dashboard. And so it focuses your attention right away on saying, is the set point right? Yes, no. Is the store doing the bidding? Yes, no. If not, why? And so rather than the iterative process that has been the industry standard for decades of individually logging into each store and verifying that something is right and using a highly skilled human to do that, you're kind of just accelerating all of that analysis is being done in semi-real time. And hopefully there's a future state where this dashboard is fully assembled and it sits at the same spot where the data is being collected. So
we'll get there next.
Yeah, exactly. So that's a future state, but I feel like that's important. That's what we are setting out to do here. And I think the other, really important thing is that not only is there an appetite on the part of the customer for the energy savings, but the utility programs who have just hit the same key on the piano for the last 10 years, doling out incentives for LED upgrades, they want to go back to the well, working inside of these same energy intensive environments with the customers that they have longstanding relationships with, and they want to drive the next tranche of savings. But they have rules. The savings have to be real. And how do you do that? You create a legit site-specific energy model with a bunch of information that you collect on site, build the model, and then run the trend data straight out of the controller through your model and say, hey, it was this was as found, this was as left, and here's how the store is performing after we've done the work. Not only did it work the next morning, it's working 90 days out. And if there's any anomaly or if things start to drift, it all boils up to this dashboard, comes to our attention immediately, and then we can essentially go back to that site remotely, communicate with a service contractor who we have a relationship with, and try to nail that down. So we want to focus on the right stuff. We want to do the right analysis, and we want to use the highest and best use of people that are skilled in this industry to make critical assessments and decisions rather than all this kind of rote data gathering. So we'd rather we want them in the operating room cutting. We don't want them out in the waiting room taking people's insurance info down and telling them that there's a 4-hour wait. So anyway.
If you guys can't tell, Will loves analogies. So we'll be sure to get some more analogies coming soon here. I think that one of the really cool parts of Dalkia's model is doing this and figuring out how to kind of put together a program at scale by inserting some technology elements and then also using utility money to pay for this for a lot of your customers. Is that right, Will?
Correct. Yes.
Cool.
So if you are, the utility programs have evolved away from the widget model of saying you have X, put in Y, you're going to get this many dollars, and said, hey, how has the store been performing now? Prove it, establish a legitimate baseline, come to us later to say that you've done something, there's measurable impact on site, that it's changed the situation. Calculate that delta using, actual, engineering analysis that's backed up by sources that are widely understood, and on a measure that's been incentivized in some fashion by the utility for a while, and they will pay to make to defray the cost of that improvement.